Alright, so here it is. If you've got it in front of you, it would be great to take notes or to listen well and wait for the video. It's going to be quite long because I think it's 12 questions, something like that. So Alan is looking at a number machine. So you've met these before. X plus 3, then take away 5, and that will give you whatever y is going to be. So he says, I know y. If I know y, I can work out x, obviously by going backwards. So I'm going to subtract 3 and then add 5. Well, it works because subtract 3 is the inverse of adding 3, and adding 5 is the inverse operation of subtracting 5. So yes, it works because he's using the correct inverse operations, and it's just 1 mark. Here, he's wrong. He wants to work out C knowing D. I can work out C if I divide by 3 and then subtract 5. That's not going to work, sir, because you've got to first subtract 5 and then divide by 3. Okay, that's what it says. The order matters here, because if you're going back this way, minus 5, then divide 3 becomes C. Alright, so no, the order of operations matters. He needs to subtract 5 and then divide by 3. Okay, so what he needs to do. So that's that. Again, if you're taking notes, great. If not, then you need to get this video. Here's question 2 with the boxes A, B and C. So look at my reasoning. Most of you didn't do all this kind of mess that I did, but this is for teaching purposes, and it's way better than just writing 3 numbers down there. So there are 62 counters in total. The first thing I did was write down A plus B plus C equals 62. Makes sense? Then it says the total number of counters in A and B is 34. So I wrote down A plus B equals 34. So the difference between these two numbers has got to be due to the C. So C has got to be 28 by subtraction. Then you plonk down the answer there. Then I'm going to read the third line. The difference between the number of counters in A and C is 9. So C take away A is 9. I know that C is 28, so 28 take away something is 9. So A must be 19. Get your answer, plonk it down there. Yeah? So I've now got 2 out of the 3. Now I want to make better use of this. I know that A and B comes to 34. I now know that B is worth, let's have a look. I now know that A is worth 19. So A plus B is 34. 19 plus B is 34. So the remaining B has got to be 15 by subtraction. And that's it. A little bit tricky, a lot of information, too many letters, too many numbers, but that's it. Many of you smashed that. Well done. Alice making cards using ribbon, make it look pretty. She's got 1,000 centimeters of ribbon. What's the maximum number of cards that she can make? Well, if you divide 1,000 by 42, she can make 23.8 cards. And there's nothing wrong with writing down 23.8, provided that's not your final answer, because 0.8 of a card, you don't round it up to 24, you just don't have enough ribbon. But you can definitely make 23 cards, yeah? How much is left over? Well, I know I'm going to make 23 cards, and each card requires 42 centimeters. So that comes to 966 centimeters, and I've got 1,000 centimeters. I've got 34 centimeters left by subtraction. I believe that should be worth 2 marks, but I'm not AQA, I'm just a regular teacher. Is that all right? So there it is, 34 centimeters. Many of you put down 0.8. I can see why you did that, but that 0.8 is not centimeters of ribbon, it's 0.8 of a whole card. So there it is, 34. This is a long question, very difficult, and I tried hard to give you marks where I saw correct steps. So I mean, look, 1, 2, 3, 4, 5. Oh, there's 6 lines before you can even start, and there's barely enough space. I couldn't make it fit. Anyway, we're going to make 400 toys. It's going to cost me £4.70 per toy. So I'm going to get 1 mark straight away. 400 times 4 times 70 is going to cost me £1,880 to make those toys. Tick, there's a mark. Now let's read this carefully. 1/4 of the toys are given to a children's home. So 1/4 of this 400 is being given away. So 100 is being given away to the children's charity. So that means I've got 300 left. Is that all right? 300 left. Because these 100 have been given away. Now it says 3/5 of the rest. 3/5 of what rest? Oh, these 300, the left over. So 3/5 of 300 comes to 180 toys. And bear in mind, this is a calculator paper. What about these 3/5? Well, they're sold for the full price of £12. Oh, okay, so I've now got to take my 180 toys and sell them for £12 each. That comes to £2,160. The remainder, this is hard, too many words. The remainder are sold at half price. The remainder of what? Well, I've just sold 3/5 at full price. The remainder must be 2/5 of the 300, and they will get sold not for £12 but for £6. So 2/5 of 300 comes to 120 using a calculator, and 6 times 120 comes to £720. So, I've really run out of space. How much profit did the company make? Well, let's take a look. We've got 2,160 sales. We've got 720 sales, so I've added those two up. Then I took away the production cost of those toys, and I was left with exactly £1,000 profit. Even though I gave some to the children's home, even though I sold some for half price, still made a profit. But there it is. That is not a difficult question in terms of maths, but a very, very difficult question getting the order correct in the story. So generally, work out the top bit, then the second bit, then the third bit, and put it all together. So it's right there, and please do look at the video when this comes through on YouTube, because you're going to need to go over it again because it's quite complicated. 8 grams of these sweeties, 12 grams of these sweeties. So the sweets are sold in bags. Each bag contains 120 grams of sweets. How many sweet A are needed to fill the bag? Oh, okay, so I'm going to take my 120 grams and divide by 8 grams for every sweetie of A style. Comes to 15 sweets. That's not too bad. They give 2 marks for that. Okay. Part B, I guess. Yeah, I did try an improvement here. Yeah. So a 120 gram bag is filled with the same number of each kind of sweet. How many of each sweet are in the bag? Okay, so all right. I want a certain number of A's, each worth 8 grams, and a certain number of B's, each having a weight of 12 grams, and the whole total must come to 120 grams as a mixed bag of sweets. So again, one of you use the method of simultaneous equations, which is brilliant. We don't do simultaneous equations till year 10. You sort of come across it in year 9 next year when we do graphs of simultaneous equations, but I wasn't expecting anyone to do that method. So here it is. Here's the story. I've got 8 times A's plus 12 lots of B's, and this must come to 120. Now it's not too difficult to get the A and the B value, because it says I'm filled with the same number of each type of sweet. So I'm looking for 8 times something plus 12 times the same something to come to 120. Well, obviously 8 times 1 plus 12 times 1 is only 20, so that's no good. Then 8 times 2 plus 12 times 2, still too low. Eventually I reached 8 times 6 sweets plus 12 times B sweets, 6 of those as well. That comes to 120 sweets altogether. Sorry, 120 grams altogether. So that requires 6 lots of A sweetie and 6 lots of B sweetie. So I require 6 of each. And for 3 marks, that's fine. That kind of trial and improvement reasoning. All right, that's it. That's a bit tricky. This is easy. 120 grams are put into boxes. The total weight of the bags in each box is 6 kilos. how many bags were dropped into the box? Well, it's 6,000. You can't mix 6s and 120s because the units are different. The units are mixed, not allowed. So 6,000 over 120, I can get 50 bags of sweeties into the box. Yeah. Now what? Oh, there's a D. All right, there's a number of ways of doing this. If I marked you right and gave you 3 marks, then great, stick to your method. There's 2 ways you can do it actually. So I've got 120 gram bag of sweeties sold for $1.99, or I can buy them loose, 100 grams for $1.59, which is cheaper actually. So I took my 199 pence and divided that by 120 grams. That came to 1.66 pence per gram. Yeah. And then I took my 159 pence and divided it by 100 grams. I got 1.59 pence per gram. So it's actually slightly cheaper to get 100 grams for 159. And you need to say so as well. Don't just give 2 sums and expect to get 3 marks. Your 2 sums might give you 2 marks, but it says which is better value. And you need to state this and give the evidence for it as well. If you were to just give that in an exam, clearly there's no marks because anyone can guess, in a 50-50 situation, well, I think it's that one. You've got to see the maths, which is why I've been begging you since year 7, and even before you were born, I was begging you to always show you working in your steps, because most of the marks are the steps. Okay, the final answer is just 1 mark. And if you've got everything right in your GCSE exam, got 1 mark for every little bit of answer, you will fail, because most of it is what happens here and how you present your steps down there on paper. Okay, good. That was an aeroplane. That's one way to do it. Bottles. Some of you got a bit confused by that. Let's unravel it. So Liz wants to drink 1.5 litres of water every day. She buys waters in a 6-pack arrangement, 6 bottles there. Each bottle is 0.5 litre. So she's bought 3 litres of water. How many packs of water does she need to buy for 10 days? Well, she drinks 1.5 litres a day, and now we're looking for 10 days. So 1.5 times 10 days, she's going to require 15 litres of water for 10 days. Now, if she buys this pack, this holds 3 litres across 6 bottles. So simply divide your 15 litres that she wants for the 10 days, divide by 3 litres, and that gives you 5 packs of those 6 bottles. 5 packs, 4 marks. It's quite generous actually. There it is. Question 7, another one of these trial and improvement type things. So these are little boys, what are they doing? So some boys are sharing some sweeties. So if each boy has 6 sweets, there will be 5 sweets left in the bag. So 6 for you, 6 for me, and there's 5 left over, which we haven't shared. If there were 3 more sweets in the original bag, we'd have exactly 7 sweets each, wouldn't we? So I tried to set up an equation with that, which I sort of solved. So here I go. I said 6 times the number of boys plus the 3 plus the 5 left over plus the 3 more that there could have been in there will come to 7 boys in total. So I worked out the equation. 6b plus 8 makes 7b. So each boy gets 8 sweets. I think that's how it works. Yeah. So, right. Now we can substitute into the original equation. If I know that b is 8, then I can say that 6 times 8 plus 5 will come to, where's the original? Yeah, 6b plus 5 should come to, what does it say? 53. But where did I get 53 from? Oh yeah, if each boy has 6 sweets, there'll be 5 left over. Sorry, yeah. So 6 times 8 is 48, plus the 5 left over in the bag comes to 53 sweets originally. So that's your final answer. Okay, 53 sweets. Sorry, I got a bit stuck there. Too many B's and numbers, I got confused. So 53 sweets. Again, watch it online. This was actually, I know this came out on the sheets with question 7. You weren't meant to do question 8. That was like for the second half. But here it is anyway. I think everyone got this right actually. So what time is the latest bus that we can catch from Killingworth? Well, Killingworth, and what time must I arrive by? I've got to get there by 11 a.m. If I take this one, get there at 10:18, a bit early. If I take that one, I get there at 18 minutes past 11, too late. So I've got to take the 10:14 bus to arrive there at 12 minutes to 11. So that's the one that we want. How long does the bus take to go from K to the water park? Well, from there to there, I can count 34 minutes, and that's just one mark. So from 14 to 48, I just took the minutes, and I saw there's 34 minutes on that bus. Yeah. Now, what about this one? Yeah, I think this was well done. Again, still the water park theme. I think it looks like I'm using Trial Improvement. The family pays £61 for tickets. I don't know what combination they're going to get. So they buy at least one ticket of each type. Well, 12 plus 10 plus 7 doesn't come to £61. Then I tried doubling 2 adult tickets and 2 children and 2 senior citizens, granddad, grandmum, grandmother, whatever. That only comes to £58. So I didn't quite make £61. Then I tried saying, let's have a mum and a dad, let's have 3 children and only 1 grandparent, and that came to 61. Again, there's no one way, no one formula of getting it in one step. You've got to try it. So I'm showing you, I'm trying it. Then I wrote down, that don't work, and I'm going with this one. So what do we require? We require 2 adult tickets, 3 children's tickets, and 1 senior ticket for grandma. All right? So it goes 2, 3, 1, but that's all the evidence up there. Now we're going to go to do some football tickets. I seem to remember this from year 7 because they've just done this one. So how much does 1 adult ticket, 1 junior ticket cost? Well, just add them up. You come to £8.40. Now what? So what's that? Josie, Jose, whatever, buys some over 65 tickets, and they cost £187.60. That's expensive. So you're going to find out how many tickets that he buys. So we're going to take out £187.60, divide by the price of the over 65 ticket. That comes to exactly 4. Okay, very easy. Now what? More trial and improvement, I think. So Kim buys 3 tickets. They all come to a total of £89.90. What types of ticket does she buy? Yeah, it's problem solving. It's exactly like this. We have to try and work it out and trial and improvement. That's a legitimate way of doing the mathematics. It's the only way in this case. So what have we got? We've got to come to £89.90. And we don't have any hints as to how many of each we're going to get. But I've got to get to that price somehow. So it's not a very big number. So I thought there's no point going 2 adults because straight away that's too much. There's no point going 2 over 65s because that's going to be too much. So it's got to be 2 juniors. So I went for 2 juniors, picked up my calculator and realised I had £46.90 left to get it up to £89.90. That's how I did it. So there we go, 2 juniors and 1 over 65 senior ticket. So 2 juniors and 1 over 65, 2 marks. Right. Which is greater is the question. So the answer is going to be that one or that one. But you have to say what it is. It's 5 marks for this, and you've got to show you're working. Well, even though it's a calculator paper, and you're using a calculator like that, you still got to show what you did on your calculator. So this is what I did. I went 68 divided by 100 times 480, and there's my answer. Then I said 3 divided by 8 times 900, and there's my answer. Now I can see that this beats that. So I give the conclusion. 3/8 of 900 is greater. Finished. 5 marks. I reckon it would be working answer, conclusion. There's your 5 steps. Another one of these things that's sort of trial and improvement. Actually, no, I set up an equation. So here we go. Again, these are weird questions, but this is GCSE. 3 positive whole numbers add up to 34. Okay, well, there's loads of combinations of getting that. I need some more information, don't I? One of the numbers is a multiple of 9. The other two are the same. So look at my setup. These are the two numbers that are the same, and I called it x. And a multiple of 9 would be plus 9, or plus 18, or plus 27. And by the way, the answers must be positive whole numbers. So I can't have a 9 there, because 34 take away 9 would be how much, Sid? 25? Yeah, and 25 divided by 2 is 12.5. That's not a whole number. So I know 9 didn't work. So then I put in an 18, and it did work. Because look, x plus x, the same two numbers that are equal, comes to 16. 34 take away 18 is 16. So I can see that the two small numbers are 8. So I've got 8 for one number, 8 for the other, and of course this 18 is the last number, and these three do add up to 34. Sorry. Okay, so it's all about reading the question really carefully and having a go. And of course you can test out to see if the answers do add up to 34 and whether it fits these two constraints. And the constraint is one's got to be a multiple of 9 and the other two have got to be the same. Okay, you've got to obey that, otherwise you may go for 1 plus 2 plus 31. Not allowed, okay? Question 12, is this the last one? No, it's not. Another massive monster question, 7 marks at GCSE. Again, not difficult maths, but millions and millions and millions of steps. Well, probably about 7 steps. It just feels like millions when you read it. So she's going to make some cupcakes. She's going to pay £20 to hire the stall and then sell her cakes in this stall in the hall, I presume. Each cupcake costs 35p to make. Now we stop and get a mark. What's it going to cost me? Well, 35p times 150 comes to 5,250 pennies. Hey, pounds. £52.50. Get a mark. She sells 3/5 of her cakes for £1.40 each. 3/5 of what? Well, 3/5 of those number of cakes. So first work out, 4/5. 4/5 of 150 is 120 cakes. And what's she going to sell them for? £1.40. So 120 times 140 is £168 worth of sales. She sells the rest. Well, who are the rest? Well, it's the remaining 1/5, because 4/5 have been sold at full price. So 1/5 of 150 is 30 cakes. And each of those will go for £1. It's towards the end of the day, she's selling them cheap, she wants to pack up and go home. So these 30 cakes, she'll get £1 for if she sells them all, and that comes to £30. And the question is, work out the profit that she makes. Well, what are the costs involved? Well, the first thing is she's got to pay for the hall, £20, and she's got to make the cakes herself with her own flour, margarine, sugar, icing, whatever. So that's meant to say a plus. It's just a bit difficult to draw it with this graphics thing. So her total costs will be £20 plus £52.50. It will cost her £72.50, okay, including the hall hire. What are her total sales? Well, she's going to get £168 plus the £30. That's £198 in sales. So how much money has she made? Well, that's the profit. 189 take away the £72.50, and the lady makes £125.50p. And what's her name? Vicky. Well done, Vicky. And that's it. And if you got that, you were thinking extremely clearly, because there's an awful lot of opportunity to get this badly wrong. And if you got this, congratulations. Again, please look at the video. There isn't time to take huge notes. What's this all about? This looks really, really awkward. Yes, it does. Is this the last question? Kind of. Oh, there's a 14 as well. Okay. Hope it's not getting too long, guys. It's a long video. The diagram shows the plan of a rectangular school hall. Okay, so that's the stage in the hall. That's the seating area in the hall. It's 26 from there right to the bottom there, and it's 20 metres across. I've got to work out the length of the seating area, just from the back right to the front where the stage is. Okay, so let's see what I did here. The stage area is 1/4 of the area of the school hall. Okay, so the whole hall area is 20 times 20, all of it, yeah? All that is 26 by 20. So I've got to do that and get a mark. Now, the stage area is 1/4 of the whole school hall. So 1/4 of this area is 130 metres squared. Okay, so work out the height h. Well, what have I got here? Yeah, if I know this area is 130 metres squares of area, if I then divide by 20, because it's only a rectangle, isn't it? H times 20 will come to 130 metres squares. So if I divide 130 by 20, I get the length h, which is 6.5. Sorry, I get that bit, which is 6.5, sorry. And then if I subtract 6.5 from the whole length, 26, I get the 19.5, just the seating area length, and there it is. Sorry, I didn't see that last bit, but there it is. Again, a little bit complicated. This is now trial and improvement, and I'll show you how I did it. The seating area has a maximum number of rows, and that's 13, and each row has a maximum number of seats, which is 16. There are the same number of seats in each row. Altogether, in that hall, we can comfortably fit 168 seats. Now I've got to work out the number of rows and the number of seats in each row, and I've got to show my working. Well, the first thing I did was to go 13 times 16, and that should allow me 208 seats, but that's not allowed. I've got to get to 168 seats. And then I thought I'll reduce this by one row, and I'll reduce this by the number of seats on that row, and that came to 180. That's too high again. Then I decided to leave that alone and reduce this by one. So I've got to reduce it down, go below 180. So I realised if there's 12 rows and 14 seats per row, I would come to exactly 168 seats. Again, this is trial and improvement. There's no direct way of getting it. And that's 3 marks. So 12 rows, 14 seats. What's this all about? Oh yes, there's some bad reading here. We didn't read it, and there's the marks scheme. So yeah, careful reading. This is the last question, I'm sure. Sorry, it's a bit long, but it's a long scenario. It's a long paper. So 120 men, 80 women. Do you drive? Is the question. 1/4 of the people. Now, people are male and female. 1/4 of them said yes. 1/4 of how many? 1/4 of 200. So that makes 50 people who can drive. 1/3 of the men. 1/3 of who? 1/3 of the men, which is 120. Well, 1/3 of 120 is 40 men who can drive. So 50 who can drive, 40 of which are men, which means 10 of them drive, and they're women. Now look at the English here, everyone, because a lot of you missed this. What fraction of the women said yes? There are not 200 women. There are not 120 women. There's just 80 women. So you've got to convert this 10 women into the fraction of the total of women. So here it is, 10 over 80, and you can leave it like that. Don't ask you to simplify it. So 1/8 of the women said, yeah, we can drive. We like to drive to work. And that's it. And that's a little bit long. I'm really sorry about that. But, you know, you'll have a chance to look at it when it goes on YouTube and take some serious notes.